Good day, my name is Nkateko and I'm with Siyabonga and Bono, who will continue after me. This is a lesson on fluid compressibility. Compressibility is a measurement of how much a fluid's volume changes when it is subjected to force, pressure, or stress. This right here is a generalized compressibility chart, and it is used to determine the compressibility factor, which is denoted as Z. We can use the reduced pressure as well as the reduced temperature to map Z right on this chart. Factor is given by this equation right here, and it is actually unitless. Note that this is just another way to find Z. The reduced pressure is given by this formula right here, and it is actually measured in bars. The reduced temperature is given by this formula, and it is actually given in Kelvin. Now let us look at this question. Given ethylene at 38.85 degrees Celsius and 10,300 kilopascals, determine Z. So as mentioned above, we're going to use the two formulas right here above, which is the reduced temperature as well as the reduced pressure. And then we substitute the values from the question into both the equation, and we get 1.1 for the reduced temperature and 2.0 for the reduced pressure. Now we then map the two values we got up here on the chart and eventually find our Z as 0.4 on the y-axis. Now let's talk more about the compressibility chart. In order to obtain the solid lines representing TR values, hundreds of experiments were conducted to get the PVT of the 10 gases on the chart. At the lower value of TR, the compressibility factor varies between the lowest values. As TR takes larger values, less variation is observed. These solid lines best fit the experimental data.
Moving on to question 2. If PR is equals to 0.1, determine the pressure value for propane. Using the formula for PR is equals to pressure over pressure to critical point for propane. Using the thermodynamics table A1, we find that pressure to critical point for propane is 42.7 bar. PR we were given in the question, which is 0.1. Then we cross multiply and find out the pressure is 4.27 bar. From the generalized compressibility chart, low PR values do not correspond with the low PC values because the PC values are constant values obtained from the thermodynamics table A1, and PR is independent of PC. When P is small relative to PC, and then PR approaches 0, hence Z approaches 1, which is part of our ideal gas. Moving on to this question. We'll use the reduced pressure equation to find the reduced pressure and the reduced temperature equation to find the reduced temperature. And we approximate Z to be 0.54. Then we calculated V using this equation, and we found V to be 9.514 times 10 to the power minus 3. Then we calculated for the initial volume, and we found the initial volume to be 0.03339 meters cubed.
Question 4.2 asks us to determine the initial volume using the thermodynamics table, which we found that propane at 100 degrees Celsius and 40 bars of pressure, propane will be superheated. We calculated the initial volume as the product of specific volume and mass. The specific volume V of propane was 0.0110 meter cube per kg and mass M as 3.5 kg. Then we calculated that the initial volume, which was 0.3885 meter cube. Question 4.3 asks about percentage error, which is equal to absolute value of the difference between calculated volume and actual value divided by actual value, then multiplied by 100. And we found that the percentage error was 14.1. Question 4.4. The above results means that the data and calculation derived from the generalized compressibility chart can be used with confidence, as the percentage error was 14.15. The ideal gas law cannot be used for propane scenario since the volume obtained using the ideal gas law is twice the actual value.